So, accurate predictions of house prices are crucial for various stakeholders, including investors and policymakers. It helps in making informed decisions like resources allocations, budgeting and prices, planning, etc. In the study, a regression analysis serves as a statistical tool to investigate the relationship between different predictors, such as areas of house, number of bathrooms, number of stories, parking spaces, and house prices. And the goal is to derive a predictive model that can guide real world applications, showcasing the power of data driven insights in construction management. Moving on to the problem statement. So the problem of accurately predicting house prices arises from the complexity of numerous influencing factors such as property size, amenities, external factors, and multicollinearity, where predictors are highly correlated, presents a key challenge. Uh, Distorting regression results. The study addresses critical questions which significantly impact the house prices and how reliable regression and mitigating these issues make to make accurate predictions. The goal is to tackle the modeling difficulties while providing actionable insights. Moving on to the dataset for my project is sourced from Kaggle, which offers a real-world scenario of house prices predictions. It consists of over 545 observations with five key features: area, bathrooms, stories, parking, and prices. The dataset is small but challenging, presenting issues like multicollinearity among predictors and mixed data types that require pre-processing. The setup also requires ideal testbed for regression model and its performance under constraints. Moving on to the methodology, sorry. Yeah. Moving on to the methodology, starting with the data pre-processing, which is a vital role or vital step in data analysis. Missing values were imputed with the statistical measures like mean to avoid losing information. Numerical features such as area were standardized using z-score for uniformity, and the categorical variables like stories, number of stories, were converted into numerical levels uh, to binary encoding. Additionally, to address the multicollinearity, I have performed a inflation factor analysis, retaining the features that significantly impacted the model performance. These steps ensure the dataset is clean and ready for the regression analysis. And moving on to the EDA, exploratory data analysis was conducted to uncover the patterns and relationship in the dataset. Correlation heat map were plotted and plotted to identify the relationship among the predictors, such as moderate positive correlation between area and bathrooms was found, and data distributors were analyzed through histograms revealing potential outliers and normality. The plots further explored in the linear relationship between predictors and house prices. This visual analysis the provided critical insights for model building and evaluation. Moving on to the regression model developed implementing the ordinary least square OLS method to predict the house prices based on multiple predictors. Model assumes linearity, independence, and normality of residuals uh, and were validated to ensure reliability. Evaluation metrics such as R squared and adjusted R squared were employed to measure the model's goodness of fit. These steps were crucial for building a statistical, robust, and interpretable predictive model. Moving on to the results and evaluation, the regression analysis provided key insights into the factors influencing house prices. Significant predictors include area, bathroom stories, and parking, with area having a highest coefficient, which is 0.324. And the key metrics such as R squared was found to be 0.549, and the adjusted R squared was 0.544, indicate a reasonable model fit, which the model performs well for lower price ranges. It struggles with the outliers at high price levels, highlighting areas for improvement in the future studies. In conclusion, the OLS regression model successfully predicted the house prices, explaining 54.9% of the variance. The analysis highlighted area, bathroom stories, and parking as significant predictors. Challenges which were included are multicollinearity and limited dataset size, which constrained the accuracy. Future work should explore advanced regression techniques such as rich or lossy regression and manage multicollinearity more effectively and improve predictive performance. This study uncovers the value of data driven approaches in housing prices prediction and construction management. Thank you, Professor.